Hi, this is Sarah again, and this is my second video on tutorials concerning the PubChem database advanced search features. In this video, I will be going into detail on some of the more useful advanced search options when concerning undergraduate students and what level of education would appreciate which search options the most. As noted before, this is the PubChem homepage, and over here you can click on the advanced search link to take you to the advanced search builder. Over here to the left is the drop-down menu to refine one's search for a specific compound. The first option I would see being useful would be Active Aid, or Bioassay ID, which is an active bioassay identifier. It is intended for users' query for active compounds for a particular assay. Related to this option a little bit further down is the Bioassay ID, which is used to search for a specific identifier of an assay from the PubChem databases. These would both be helpful for students in the field of chemical research or possibly in biochemistry when searching for experiments testing specific compounds. The next set of options I see being very helpful are the atom chiral count. Atom chiral count is used as the total count of chiral atoms in a given molecule. Atom chiral defined count is used to describe the total count of defined chiral atoms in a given compound, defined meaning proven. Atom chiral undefined count is used to describe the total count of undefined chiral atoms in a given compound, as in specifically not proven to have a specific chirality. These options would be very helpful for someone at the level of organic chemistry specifically, as this is where one learns about chirality. Next, I would like to focus on the options grouped into this category of bond chiral count. Bond chiral count is used to describe the total count of non-rotatable double bonds in a given compound. This is helpful in determining diastereoism, which I will talk more about in an upcoming video. Second, there is bond chiral defined count, which is used to describe the total count of defined non-rotatable double bonds in a given compound. Then there is bond chiral undefined count, which is used to describe the total count of undefined non-rotatable double bonds in a given compound. Next would be the group on synonyms. Synonyms, which deals with naming. The complete synonym option here is used to search for a compound specific to the name of interest. And down here a little further is simply synonym, which will search for all compounds which have your search query as a string within the name of a compound. So it is like a partial match, whereas complete synonym is more of an exact match. These options would be useful to possibly organic students when searching for different enantiomers of a specific name, or for research students when having to look up related compounds based on naming. Now over here is complexity. Complexity option is used as a method in searching for a measure of structural complexity. I could see this option being useful mostly to biochemistry students or research students, such as graduate students. Next, the compound ID is used as the PubChem compound identification, a non-zero integer PubChem associated identifier for a unique chemical structure. This option would be useful for research or graduate students, also for cheminformatics students. And down here is the element option. This element option is used to search for a specific element within a compound. Then the exact mass option is used to search for the calculated mass of an ion or a molecule for your specific compound. Both of these options would be most useful for a general chemistry student or possibly an organic chemistry student. The next group that I could see being very useful for organic chemistry students, biochemistry students, or graduate students would be the Feature Acceptor Count 3D option, as it is used to search for the count of acceptor features per compound. The Feature Anion Count 3D option searches for count of anion features per compound. The Feature Cation Count 3D option is used to search for the total number of 3D features per compound in cations. Then the Feature Count 3D option is used to search for the total number of 3D features in a compound. The feature donor count 3D option is used to search for the count of donor features per compound. Then the feature hydrophobe count 3D option is used to search for the count of hydrophobic features per compound. The feature ring count 3D option is used to search for the count of ring features per compound. All of these options would be tremendously useful in searching for compounds reacting in specific ways mechanistically with other compounds, thus being able to predict the chemical mechanism. Then the heavy atom count option will allow one to search for the total number of compounds in atoms in a compound excluding hydrogens. I could see this option being of use to all levels of chemistry students. The hydrogen bond acceptor count option refines the search to the number of hydrogen bond acceptors for a compound. The hydrogen bond donor count refines the search to the number of hydrogen bond donors for a compound. Both of these options would be useful in areas of organic and biochemistry, as well as at the graduate research level. The IUPAC name option is the International Union of Pure and Applied Chemists name, which is the official naming system of compounds. This option can be used to search for a compound by its official name and would be useful for organic students as well as graduate level students. The INCHI option is the standard IUPAC International Chemical Identifier. The INCHI is a non-proprietary identifier for chemical substances that can be used and printed in electronic data sources, thus enabling easier linking of diverse data complications. Then the INCHI key is the standard IUPAC International Chemical Identifier key. Both of these search options would be most useful to cheminformatics students. Then down a little further is the molecular weight option, and it is the mass of a molecule calculated using the average mass of each element weighted for its natural isotopic abundance. This is different from exact mass, as it is an average based on all available isotopes. This would be useful in all areas of chemical study. Then down a little further is the substance ID option, and it is the substance identifier and would probably be of most use to cheminformatics students. Then the tautomer count option is the total number of possible tautomers for each given structure, but it has a limit of no more than 200. Then down here is total formal charge, and it is based on the difference between the number of valence electrons of each atom and the number of electrons the atom is associated with. These two options would be most useful for organic students and graduate students, as they can be helpful in the prediction of mechanisms of specific chemical reactions. Now, I know that all of this can be a lot, but once you get the hang of how to use all of these different resources, it can really make your journey in the world of learning chemistry that much easier. And in my next video, I will begin to do some searches using the search builder to show you how to work it firsthand. Thanks for watching.